Alright, let's take a look at a question regarding operations of functions. So here we have two functions, f, and we have a series of ordered pairs, 0 and 6, 1 and 3, 4 and 7, 5 and 8. And we have another function, g, which has an ordered pair set of negative 1 and 2, 1 and 4, 2 and 3, 4 and 8, and 8 and 9. Okay, so we want to determine the following. The first is the sum of the two functions, f of x plus g of x. Now, when you're adding functions, you have to add the same x values, right? So you add the y values of the same occurring x values. Here's an example. If I wanted to add f of 0, I'd have to add it with g of 0, except for the fact that there is no g of 0. So you need to look at anything that basically has the same x values, right? So in this case, I can only see 2 points that have the same x values, so I can only potentially add those 2 points together. So for part A, I can do f of 1 plus g of 1. So f of 1 here is 3 plus g of 1 here is 7. Oops, sorry, 4. And this is going to give us 7. Okay, so f of 1 plus g of 1 is equal to 7. Or you can write this as f of g of 1 is equal to 7. Okay. We can also add f of 4 and g of 4 as long as the x values are the same. And in this case, we'll get f of 4 here is 7. G of 4 here is 8. We'll get 15. So f plus g of 4 is equal to 15. Okay, so you can actually get these points and plot them, and you'll actually get a different kind of function as the sum of these two functions. So the graph actually will look a little different. So it's a combination of these two functions, really. Let's take a look at part B. So it's the same rule for subtraction, multiplication, and division, right? For subtraction, f of x minus g of x, so you use the same rule, you have to keep the x's constant. So in this case, I can only subtract f of 1 minus g of 1. So if I do f of 1 minus g of 1, f of 1 here was 3. G of 1 here was 4. Oops, was 4. Excuse me. So 3 minus 4 here is negative 1. And the other point that we can actually use here is f of 4 minus g of 4. And in this case, f of 4 minus g of 4 is going to give us f of 4 here is 7, g of 4 here is 8, and this is going to give us negative 1. Okay, so when you do write this out, right, you really want to include the ordered pairs. So in the first case, you know how we had f plus g of 4 is equal to 15. You want to write the point as 4 and 15, and we know that f of g of 1 was 7, so the point here is 1 and 7. So these are the new points of the f plus g ordered pair set. Okay, so you can write this down as 1 and 7, and 4 and 5. Sorry, 4 and 15. Whoops. Okay, so you can do the same thing for this, right? So in the f minus g set, right, you would basically get 1 and negative 1, as well as 4 and negative 1. Okay, so this was a negative 1 as well. Okay, so that's the two combined sets that we've looked at. Excuse me. Let's take a look at part C. So you have f of x times g of x. So you do the same thing. You do f of 1 times g of 1, which is basically 3 times 4, which is 12. And we can also do f of 4 times g of 4, which is 7 times 8, which is 56. Okay, so in this set, f times g, you can have the points 1 and 12, and 4 and 56. Okay, so that's how we can combine functions into. Alright, if f of x is equal to 2x and g of x is equal to x squared minus 15, what is g minus f of 3? So if you're looking at subtracting two functions, g minus f of 3 is equivalent of writing g of 3 minus f of 3. So to figure out what g of 3 is, I'm going to plug this into my g of x function, x squared minus 15. So you get 3 squared minus 15, which is 9 minus 15, which is negative 6. f of 3 here is equal to 2 times 3, because I'm plugging in 3 into my function f of x, which is equal to 6. So g of 3 minus f of 3, which is basically the same as g minus f of 3, is equal to negative 6 minus 6, which is negative 12. Okay, so that's your answer. Alright, given the graph of f of x and g of x as shown, sketch f minus g of x on the same grid, plot at least 4 points. Okay, so to do this, we know that f minus g of x is equivalent to f of x minus g of x, and you can only combine two functions as long as the x values are consistent. So what I'm going to do here is I'm going to figure out some points on f of x and some points on g of x. They want at least 4 points. Let's start with g of x first. Okay, so in my g of x function, I'm just going to figure out a few points here. So we have negative 2 and 0, right? Whatever x values I choose for my g of x function, I'm going to also look at my f of x function. I can also see negative 1 and 1. Okay, 0 and 4. Right, 0 and 4 here. And also 1 and 3. Okay, so the points are pretty easy to kind of interpret here, so it won't give us too much trouble. Let's take a look at f of x. Okay, so for our function f of x, we have negative 2 and 0 as well. We also have 1 and negative 1 and 1 as well. Oh, I think I made a mistake here. This one was negative 1 and 3. Okay, I think I looked at f of x instead. So for g of x, the equivalent point is negative 1 and 3, so it should have been this point. Okay. Anyways, continuing with f of x, we also have 0 and 2, and we also have 1 and 3. Okay. So what I want to do now is I want to do f of x minus g of x. So you have to use the equivalent values. So in this case, if I do f minus g of negative 2, that's f of negative 2 minus g of negative 2, which is basically, so f of negative 2 is 0, g of negative 2 is also 0, which is 0, right? So the point here, and if I'm looking at my f minus g, I'm just going to do it here. If I'm looking at points, I have negative 2 and 0 as well. Okay. Then I also do f minus g of negative 1. So you do the same thing, f of negative 1 minus g of negative 1, which is, so negative 1 for f is 1. Negative 1 for g is 3. So you basically get negative 2, right? So the point here is negative 1 and negative 2. Then you do f minus g of 0, which is f of 0 minus g of 0, which is f of 0 here is 2. G of 0 is 4, so you get negative 2. So the point here is 0 and negative 2. And the last point, f minus g of 1. So f of 1 minus g of 1. F of 1 here is 3. G of 1 here is also 3, and you'll get 0. So you get 1 and 0. Okay? So these are the 4 points, and you can just kind of plot these 4 points to create your graph. So I'm going to just do that on this grid. So negative 2 and 0, so we're going to have a point here. I'm just going to do it in orange. Negative 1 and negative 2, it's going to be here. 0 and negative 2 is going to be here. And 1 and 0 is going to be there. Okay, so I'm just going to plot these points. Usually you wouldn't draw a line through them because sometimes the points in between might not be consistent. So I'm just going to plot the points here. Alright, the graph of y is equal to f of x minus g of x is shown. Determine the approximate solution to the inequality f of x is less than g of x. Well, if this is our graph, f of x minus g of x, right? If you want to figure out, so this is a combined function, if you want to figure out f of x is less than g of x, what I'm going to do here is I'm going to move the g of x to the other side, so you get f of x minus g of x, and you can actually notice that this is less than 0. So this is basically our combined function, f of x minus g of x, we just want to, in order to solve our inequality, we just want to see if, we want to figure out which values of x would make this inequality less than 0, right? So if you want to figure out when it's less than 0, we just have to look at the point of the graph where it's negative, right? So you can notice that the point of the graph where the function is negative, it looks like this point and this point, right? Because everywhere beyond the x-axis, above the x-axis is positive, below the x-axis is negative. It's only this portion here that's negative, right? So it looks like 4 and 2.5. So the approximate inequality here, x belongs to, and I'm just kind of ballparking this, but well, it could be 3 and, actually, you know what, this is 3. Okay, so this point here is 3, so it looks like 3 and 2.5. Okay, so I'm going to say x belongs to 2.5 and 3, and we're going to do it within the interval, so it's not inclusive of the endpoints because those are values of 0, right? So we're looking for negative values, so values that don't include 0. So between this interval, we're going to have f of x is less than g of x. Alright, let's say we want to determine the function f times g of x and we wanted to graph it, right? So, quick way we can do this is we'd have to find some points on each of these functions, f of x and g of x. I'm going to start with g of x. So one of the easy common points we can see here, the g function will have 0 and 3. So I'm going to look for points that have common x values that I can kind of discern from. Now there's also 1 and 2. Okay. There also looks like 2 and 1. And 3 and 0. Okay. And we can also look at 4 and negative 1. Right? So these ones are pretty straightforward. We don't need a lot of points, right? And you can also look on the other way. Let's take a look at a few points on f of x. Okay, this one isn't so clear cut. Some of these points are, so there's negative 5 and 0. Some of these points are kind of in between the squares that you can kind of see. You should also see 0 and 3. This point here is pretty common, so this is like 5 and 6. This point is close, but it doesn't really touch. So I'm just going to look at the points that we can easily identify. All right. So using these points, so we can see that f of x has the points negative 5 and 0. We also see 0 and 3. We also see the point 5 and 6. So I'm just going to find what the equivalent g values are here. So we can basically look at, and I'm going to find the g value at negative 5, but there's an arrowhead there, so can't really tell, right? It should be negative 5 and negative 8. Okay, so negative 5, negative 8. Whoops. Drew the infinity sign. Okay, so what we want to do here is we want to find f times g of x. So if f times g, and if we want to just look at it as points, right, we can look at some common points. So we can do f times f of g of negative 5. So f of g of negative 5 is going to look like f of negative 5 times g of negative 5. So f of negative 5 here is negative 8. G of negative 5 here was, whoops, f of negative 5 was 0. Sorry about that. F of negative 5 is 0. G of negative 5 is negative 8. Right? So f of negative 5 is 0. G of negative 5 is negative 8. And in this case, we get 0. Right? So we get negative 5 and 0 as one of our points. Okay? Let's take a look at another point. So let's say we have another common point. You can notice here there's a 0 and a 0 here. So let's do f g of 0. So we get f of 0 times g of 0. And f of 0 here looks like 3. G of 0 here is also 3. So we get 9. So the point here is 0 and 9. Okay? Let's take a look at another point. Another common point that these guys have is looks like 5 and 6, and we can also look at, whoops, you can also look at 5 and -2, right? So this guy has 5 and -2. Didn't write that in order, but it's fine. So in this case, if we do f of g of 5, we basically get f of 5 times g of 5. So f of 5 here looks like 6. G of 5 here looks like -2, and we basically get -12, right? So we get 5 and -12. So you can plug all of these points in, you can get some idea. And this probably wouldn't be a linear function, right? The combination of functions, in most cases, this would probably be somewhat of a quadratic, right? And we can understand this if we take a look at g of x. G of x, kind of, if you look at rise and run, right? It basically looks like slope of -1. Right, so let's just use a different color for this. But if you look at g of x, the slope here is -1, and you can see that the y-intercept is 3, so g of x should look like negative x plus 3. And if you looked at f of x, right, if you looked at f of x, you can see that the slope here, right, this is 3, and then this is like 5, right, and the y-intercept is, so if you look at rise and run here, you get 3 over 5x, and it's going to be positive, and the y-intercept here is 3, and if you multiply these two, you can see that we should get a quadratic function, right? Like if you did g of f of x, or f of g of x, it should be the same thing, right? Let's do f of g of x, just keep it consistent. If you do f of g of x, it's just going to be a combination of these two multiplied together. So we have -x plus 3 times 3 over 5x plus 3. So you can actually see that this would actually become a quadratic function, right? So if you plot some of these points, right, we had -5 and 0, 0 and 9, which is going to be on the page, right? 5 and -12, which is going to be beyond the page. You know, we're gonna actually see that this would be a quadratic function. So this is how we combine functions together graphically. Alright, given the function f of x is equal to sine x and g of x is equal to 3, determine the range of the combined function y is equal to f of x plus g of x. Well, we understand that the combined function y, f of x is sine x, g of x is 3, so the combined function is y is equal to sine x plus 3. Now we know that sine x will have a range of greater or equal to -1 and less than or equal to +1, right? Because if I construct a sine graph, I'm going to do that here. Okay, let's make this +1, -1. You know, this is like pi over 2. This is pi, so this is also equivalent to 90 degrees. I'm just going to do this in radians, and I'm going to do x is basically between 0 and 2 pi radians. Right, so this is 3 pi over 2, and then this is 2 pi. And if I look at the sine graph, sine 0 is 0, sine pi over 2 is 1, sine pi is 0, sine 3 pi over 2 is -1, sine 2 pi is 0, right? So the graph is going to kind of look like this, right? And it's going to keep repeating, so if you keep adding points, so if this is like 5 pi over 2, then you're going to get, it's basically equivalent to pi over 2. So it's going to keep going. That's why it's called a periodic function. And if you go the other way, negative pi, you're going to get like -1 and so forth. So it's going to keep going. It's going to repeat. But you can notice here that the maximum y value here is 1. Okay, so this is your maximum y value. The minimum y value here is -1. Okay, so this is your minimum. Okay, so because of that, the range is still going to be found in there. Between -1 and +1. However, because we're adding 3 here, you're going to have to add 3 to your minimum point and 3 to your maximum point. Okay, so the new range here, I'm going to just use a different color, but the new range here is basically 2 and 4, because you're doing a vertical shift 3 units up. Okay, so you look at the range of the parent function, which is sine x, which I did out here, y is equal to sine x, and then I added the transformation to it, and that's your range of your combined function. Right, y is greater or equal to 2, but less than or equal to 4. Alright, given the functions f of x is equal to cosine x and g of x is equal to x squared minus 5x minus 6, determine the domain of the combined function y is equal to f of x over g of x. So in this case, you're finding the quotient. It's y is the combined quotient of f of x and g of x. It's going to create a rational function. So y here is equal to cosine x over g of x, which is x squared minus 5x minus 6. Excuse me. And then what you want to do now is you want to determine the domain, so you have to look for restrictions. So what I'm going to do is I'm going to assess the denominator, and you can actually see that this is a quadratic trinomial that is factorable, right? So think about quadratic trinomials as ax squared plus bx plus c. I'm going to factor the denominator here, so x squared minus 5x minus 6, a here is 1, b here is negative 5, c here is negative 6, right? I'm going to factor this by decomposition, where I need to find two numbers and multiply to AC, which is negative 6, that add up to negative 5. So the two numbers I can use for that is, let's do negative 6 and positive 1, right? So in this case, what I want to do here is I'm replacing this with my middle term, so x squared minus 6x plus x minus 6, and if I factor this out, you get x minus 6 times x plus 1 x minus 6. You get x plus 1 and x minus 6. Now, excuse me, what you want to do now is I'm going to plug this back in. So y is equal to cosine x over x plus 1 times x minus 6. So you can already kind of tell that your domain here is x belongs to all real numbers, but x cannot equal negative 1 and 6. Now, it's also important to understand that x should be in radians, right? So because x is in radians, you can have a value that is greater than 1 or less than 1, negative 1, right? So this is your domain, negative 1, and x belongs to all real numbers, x cannot equal negative 1 or 6. Alright, the zeros of a function f of x are 3 and 4, while the zeros of a second function g of x are 3 and 7. What are the zeros of the function y is equal to f of x over g of x? So we can understand that this is going to be a rational function, and we know that the zeros of g of x are going to include restrictions, right? When g of x is equal to 0, these are the restrictions on the domain, and specifically these values that make g of x equal 0, this is going to include are going to be our vertical asymptotes. Okay, so it tells us that the zeros of g of x are 3 and 7. So I'm just going to make basic factors for 3 and 7, so x minus 3 and x minus 7. So this is what g of x can potentially equal. You can add an a value in front of it, so you can change the multiple, right? You can add an a here, but I'm just going to let a equal 1. So g of x here is equal to x minus 3, x minus 7. F of x is the numerator, and basically when f of x is equal to 0, these are going to be your x-intercepts. So the values that make f of x equal 0 are going to be your x-intercepts, and in this case the zeros of the function are x minus 3 and x minus 4. And then what are the zeros of the function y is equal to f of x over g of x? Well, the zeros of the function, so basically the function y can be equal to x minus 3, x minus 4 over g of x, x minus 3 times x minus 7. And you can see that the zeros initially will be 3 and 4 because it's only going to be the x-intercepts. So the x-intercepts are another name for zeros. However, we know that there is excuse me, there is a hole that occurs at x minus 3. So when x is equal to 3, you can see that y is going to actually equal 0 over 0, right? Because 3 minus 3 is 0, 0 times x minus 4 is 0, and the denominator will also be 0, right? So you're going to get 0 over 0. So in this case, 3 would not be considered a 0. So there should be a hole at x is equal to 3, right? There should be a 0 at 4 when x is equal to 4. So the point here is 4 and 0, right? And if you want to find if you want to determine the point of the hole, what you could do here is if you simplify this, this is what your new function of y will equal, x minus 4 over x minus 7. If you plug in I'm just going to use f of x for this, it'll be easier to plug in. If you plug in f of 3, you basically get 3 minus 4 over 3 minus 7, which is negative 1 over negative 4, which is 1/4. So there's a hole at 3 and 1/4, right? And beyond that, we will also see vertical asymptotes at x is equal to 4 and x is equal to 7, right? So basically this is the summary of our function y is equal to f of x over g of x. Okay, so Jason is a writer who gets paid a certain number of dollars per page, but 25% of the money he makes goes to taxes. Suppose dp represents the number of dollars Jason gets paid as a function of the number of pages he writes, and TP represents the number of Jason dollars that go to taxes. If TP is equal to 400, what is the value of DP minus TP? Okay, so I'm just going to reiterate that DP is amount Jason is paid after P pages written. Okay, and TP is equal to amount of money for taxes, of money that goes to taxes. Oops. That goes to taxes. Should have said page. Both of these cases are in dollars, right? We also understand that the amount of money he goes to taxes is 25% of the money that he makes, right? So TP is equal to 0.25 or 1/4 of DP, right? So we want to figure out the value. What is DP minus TP? Well, what you could do here is we know that the amount of money that he that he pays for taxes is 400, right? So if the amount of money that he pays is 400, we can understand that dp here, 0.25 dp is equal to 400. So dp, if you multiply this by 4, multiply 400 by 4, you basically get 1600. So Jason makes a total of 1600, right? So if I put this into my function, we basically get 1600 minus 400 for taxes, and basically in total he makes 1200, right? So the DP minus TP is the amount of money that he takes home at the end of the day, right? So therefore the value DP minus TP is equal to 1200, and this represents the amount of money that Jason makes after taxes. So this is, you can think about this as net income basically. Okay, so Jack and Jill work at the same store. Jack's total weekly salary in dollars if he sells X items is given by S is equal to 100 plus 5X. And Jill's total weekly salary in dollars if she sells X items is given by S is equal to 80 plus 6X. Assume that they sell the same number of items in a week. What is the minimum number of items they have to sell so that Jill's weekly salary is at least $100 more than Jack's? Okay, well, let's say that, I'm going to do this in red. Let's say that I'm going to use J of X for Jack. Okay, and we'll use lowercase j of x for Jill, right? And we can see that Jack's total weekly salary in dollars, right? So this is I'm going to use J of X for total weekly salary, right? And this is Jack's in dollars. And after X items sold, and I'm going to use lowercase j of x. This is the total weekly salary of Jill in dollars after X items sold. Whoops. Okay, so we can understand that Jack's total weekly salary, J of X, is equal to 100 plus 5X. Okay, I just switched up the variables. And Jill's total weekly salary is 80 plus 6X. Assume that they sell the same number of items in a week. What is the minimum number of items they have to sell so that Jill's weekly salary is at least $100 more than Jack's? So if you're looking at Jill's salary being at least 100 more than Jack, so you're doing 100 plus Jack's salary, right? What we want to do here is we can understand that Jill's salary wants to be, it's a function of Jack's salary, right? So because we're using the word at least, I think, so because it says at least $100 more than Jack, we should express this as an inequality. So J of X is greater or equal to 100 plus Jack's salary, right? So Jill's salary, we know that it can be expressed by the expression 80 plus 6X is greater or equal to 100 plus Jack's salary here is expressed by 100 plus 5X. What I want to do here is I want to solve for my variables. I'm going to move the 5X to this side. I'm going to move the 80 to the other side. So you get 6X minus 5X is equal to 100 plus 100 is 200. Oops, sorry, don't use the equal sign. Let's use the inequality. Greater or equal to 200 minus 80. So in this case, we get X is greater or equal to 200 minus 80 is 120, right? So in this sense, what Jill needs to do here is, therefore, Jill needs to sell at least, or a minimum of, 120 items so that her salary is at least $100 more than Jack. So that's how you can use inequalities to express combinations of functions and so forth in application of a variety of different operations by using a variety of different operations.